Hello Year 10, welcome to week 5 of your online maths. Can't believe it's week 5 already, can you? Okay, so before you begin, you will need a black pen, a green pen, calculator and some paper, and also a nice quiet place to study. So please could you now write the title Quadratic Simultaneous Equations and the subtitle 5 a day. It's just over here. If you need to pause to do that, hit pause now. Okay, so the learning objectives for today are to solve simultaneous equations by equating and then solve quadratic simultaneous equations. So a really exciting lesson today. I'm really looking forward to it, and I know you are too. Okay, so 5 a day as usual. So I would like you to spend 5 minutes answering these questions, and as soon as that 5 minutes is up, you can hit play. So pause now. Okay, 3, 2, 1, pens up, drop, green pens and mark. So the answers are on the screen now. If you need to pause, hit that pause button. Okay, so now I'm going to show the worked solutions. So if you need to pause, you hit pause. Okay, so could you now write the subtitle Retrieval Practice? If you need to pause, hit pause. Okay, in our retrieval practice today, we're going to look at solving quadratic equations because that is what we need for today's lesson. So if we remember, well, what are the 3 ways that we can solve quadratic equations? Excellent. So by factorising using the quadratic formula or completing the square. So there's our quadratic formula as a reminder. Okay, so let's have a look. So we've got these 2 quadratic equations. So I'm always looking to factorise if I can, because factorising is the quickest of the 2. And then if you can't factorise, you either complete the square or you use the quadratic formula. For those second 2, it's probably easier to use the quadratic formula, but if you like to complete the square, like I do, you can complete the square. Okay, so for that first example, we could factorise, and that's the answer. And then for the second example there, what we need to do, we need to use the quadratic formula. So we've got our A and our B and our C, remembering that our B also includes whatever the sign is. So it could be positive or negative. That's the same for our C too. So then we substitute into this equation or into the formula, and then we get our answers. Remembering that we type this in and we do plus or we do minus. And I've just left the answers there to 1 decimal place. Okay, so now it's your turn. Let the retrieval practice begin. Okay, question 1. Solve x squared plus 5x plus 4 equals 0. This can be factorised. 3, 2, 1, green pens and mark. So the answer is x equals -1 or x equals -4. I've just added that 0 for completeness. Okay, question 2. Solve x squared plus 6x take away 16 equals 0. So this can be factorised if you wish. 3, 2, 1, green pens and mark. So the answer is x equals -8 and x equals 2. Okay, next one. Question 3. Solve 5x squared plus 13x plus 6 equals 0. So this can also be factorised if you like. But if you want to use the other 2 methods, that's fine too. Okay, 3, 2, 1, green pens, and mark. Okay, question 4. Solve x squared, take away 7x plus 12 equals 0. So this can be factorised, but you can choose the method that you prefer. Okay, 3, 2, 1, green pens, and mark. Final question. Solve 4x squared plus 4x plus 1 equals 0. So this can be factorised, but it might be a little bit tricky, so you might want to use the quadratic formula. 3, 2, 1, green pens, and mark. So that's factorised. So we've got the answer is x equals -1/2. So that's strange. Why is there only one solution there when it's a quadratic? Okay, let's have a look. So this is the graph. So occasionally we might have a quadratic where just the minimum point or the maximum point just touches the x-axis. So if that happens, there is only one solution. Okay, so well done there. So what I'd like you to do now is I'd like you to give yourself a retrieval practice score out of 5, and if you need to pause to do that now. Okay, so today we're going to be solving quadratics by equating equations. So let's have a look at these 2 examples now. Okay, so this is not a quadratic. We've got 2 linear equations here, and they're both equations of lines. But I thought to warm us up, we'd have a go at some linears to start. Okay, let's just change the focus. Okay, so we've got y equals 3x plus 1 and y equals 2. So both of these equations are equivalent to y. So what we can do is we can do something called equating. So let's write that down. Let's equate the equations. And we can do that because y equals y. Just like 1 equals 1 or 5 equals 5, if this is y and this is also y, we can say that this 3x plus 1 equals 2. So we can write this y first. So we've got 3x plus 1 and then equals the other y, which is 2. And now all we're going to do is we're going to solve this equation. So we take 1 away from each side, we're left with 3x equals 1, and then we're just going to divide both sides by 3. So we're left with x equals 1/3. Okay, so to check, we've already been given what a y is, because y equals 2, but just to check, we can just substitute this back in. So x equals 1/3 into y equals 3x plus 1. So we've got y equals 3/3 plus 1. So we've got y equals 3 times 1/3 is 1 plus 1, which is 2. So we've got x equals 1/3 and y equals 2. And that's it. So what I'd like you to do now is I would like you to pause the video and I would like you to copy down that example. So you can do that now. Okay, so now we've got our second pair. So what we could do, we could just eliminate this, but I want us to practice equating. So let's equate those equations. Because they're both equal to y, we can just say that they're equal to one another because y is the same as y. So we've got the first y is 4x take away 2, and then we've got equals, and the second y is 2x plus 3. So now what we're going to do is we're going to rearrange this equation. So let's move the x's over here. So let's take 2x from both sides. So we're left with, on the left-hand side, 2x take away 2, and on the right hand side we're left with 3. Now let's move this across, so let's add 2 to both sides. So we're left with 2x equals 5, and then we finish it off by just dividing both sides by 2. So we're left with x equals 5 over 2. So now we need to work out what y is. So what we're going to do is we're going to substitute this into this equation here. So if we substitute x equals 5 over 2 into y equals 2x plus 3, we're going to have y equals 2, 5 over 2 plus 3. So we've got y equals 2 times 5 over 2 is just 5 plus 3, so we've got y equals 8. So we can say that x equals 5 over 2 and y equals 8. Just there at the bottom. Okay, so what we need to do now is we need to check this. So what we're going to do is we're going to substitute this into our other equation to check. So if x equals 5 over 2, we've got 5 over 2 multiplied by 4, so that gives us 10. So it's 2.5 times 4, which is 10. Take away 2, which is 8. And then we worked out that y equals 8, so we know that that's correct. So what I'd like to do now is I'd like to copy down this example and I will move it. Okay, so copy it, hit pause, now. And the second part, hit pause, now. Okay, back to the PowerPoint. Okay, so now it's your turn. Solve these simultaneous equations by equating. Hit pause. 3, 2, 1, pens up, drop, green pens, and mark. So we've got x equals -2 and y equals -5 for the first one. For the second one, we've got x equals -2 and y equals -3. And if we have a look at the graph, for the first one, you can see that's where the two lines intersect. Okay, moving on to the next section. Okay, so these are the solutions for those two examples if you need to check. So just hit pause. Okay, moving on. So now it's time for you to try. So there's 3 practice quick questions, and I would like you to solve these by equating. So I want you to spend no longer than 6 minutes on this. So after 6 minutes is up, you hit play and the answers will appear. Okay, 3, 2, 1, pens up, drop, green pens, and mark. So well done there, that was excellent. Okay, moving on to the next section. Okay, so now it's time for a little bit of theory again. So when we solve quadratic simultaneous equations, we are finding the coordinates of the intersections between the two graphs. So let's have a look. So if we've got y equals x plus 3, so this is a straight line, and then we've got y equals x squared plus 5x minus 2. So that is a parabola, or our classic quadratic graph. So if we look at the graph, we can see that they actually intersect at 2 points. So we can see that they intersect here, or cross here, and they also cross here. So what that means is that when we're solving simultaneous equations like this, where we have quadratics, we're going to have 2 possible solutions for x and y. So very important, we have 2. Okay, moving on. Okay, next one. Solve the simultaneous equations y equals x squared plus 5x take away 4 and y equals x plus 1. Okay, switching to the visualizer now. Okay, so here are 2 equations. So we're going to use the same technique that we've just done for solving the 2 linear equations. So the first step is to equate. So remember, equate is to make equal to one another. So we know that y just equals y, isn't it? So we're going to have the first y, which is x squared plus 5x take away 4 equals the second y, which is x plus 1. Okay, so now we're just going to rearrange this to make a quadratic equation. So what we need to do, let's move the x's across first. So if we take away x from both sides, we're left with x squared plus 5x take away x is 4x, take away 4, and on the right hand side we're left with 1. And then what we're going to do is we're going to take away 1 from both sides. So we're left with x squared plus 4x take away 5 equals 0. So now we can solve this quadratic. So a lot of the questions you're going to see now, you'll be able to solve by factorising. So that's the first thing that we should look to, because factorising is a nice, quick method of solving these equations. Okay, so this is a normal quadratic, so we don't have a coefficient of x squared. So we know that our two numbers, they have to multiply to make -5, and they have to add to make 4. So let's do it the longish way. So we're trying to find the factors of 5, or -5. So our two numbers could be 1 and -5, or they could be -1 and 5. So if we add those, we can have -4 here, we'll have 4. So I can see this is what needs to go into our brackets. So to factorise that, we're going to have x take away 1, and we're going to have x plus 5 equals 0. Okay, so now we've got x take away 1 equals 0, or we can have x plus 5 equals 0. So that leads to x equals -1 and x equals -5. Sorry, not -1, x equals +1, because we are adding 1 to both sides. Okay, so now what we need to do is we need to substitute each one of these into our equation here to get a value for y. Because remember, if we think back to our graphs, there is going to be 2 solutions. So first of all, we're going to substitute x equals 1 into y equals x plus 4. So we're going to have y equals 1 plus 1, so we get y equals 2. And then we're going to substitute x equals -5 into y equals x plus 1. So we have y equals -5 plus 1, so we get y equals -4. And then it's a shame that we've run out of space at the bottom of the page, because for the final step we just want to say, so we've got x equals 1, y equals 2, so that's our first solution, and we have x equals -5 and y equals -4, like that. So what we can do now is we can do a check, so we can put them back into this top equation. So we've got here y equals 2 on the left hand side, and then on the right hand side x squared, 1 squared is 1, plus 5 is 6, take away 4 is 2. So we know that's correct. Now let's try this one. So y should be negative 4. So x squared is 25. Then we're going to add 5 times negative 5, which is negative 25. So that equals 0. Take away 4, which is negative 4. So we know that our two solutions are correct. So what I'd like you to do is I would like you to now copy down this worked example. So I'm going to do a few pauses. So copy that down and hit pause. Okay, now hit pause. And finally, hit pause. Okay, let's go back to the PowerPoint. Okay, so now it's your turn. Have a go and remember to do that equating step, then we rearrange to get a quadratic to equal 0, and then we solve, and final step is to substitute back in. Okay, so hit pause now. 3, 2, 1, pens up, drop, green pens, and mark. So we've got x equals negative 3 and y equals negative 4, and we've got x equals negative 4 and y equals negative 6. So if we look at the graph, looks like this. You can see there the 2 points where the two graphs intersect. So well done there. I know these are a little difficult, but if you just trust in the method and go step by step, you will have the prerequisites to solve these problems. So let's move on. Oh, okay, so here are the worked solutions if you need to check your answer. So just hit pause if you need to now. Okay, so your turn. So where can I go? I'm not in the way. Here I am. Okay, so as you've probably noticed, we're only 20 minutes in, which is great. But the reason for that is I want you to have a really good practice with solving these quadratic equations, quadratic simultaneous equations. So I would like you to spend the next 20 minutes or until you have 5 minutes before the end of the lesson, because it's really important that you practice the skills here. So remember, step 1, we equate. So we make it so y equals y. So for this first equation over here, you should have x plus 3 equals x squared plus 5x take away 2. Second step, you're going to rearrange so you get a quadratic which equals 0. And at that point, you can solve. So you can either solve by completing the square, factorising, or using the quadratic formula. Once you've solved that quadratic, you will have x equals something and x equals something else. So you'll have 2 solutions most of the time. And then you're going to substitute it back in to this y equals to get your 2 solutions for y. And that's it. So what I'd like you to do is I would like you to pause and have a go at those now, and then hit play in 20 minutes time. Okay, 3, 2, 1, pens up, drop, green pens, and mark. So these are the answers for question 1. And these are the answers for question 2. Okay, exit ticket time. So what I would like you to do now is I would like you to write the subtitle exit ticket, and I would like you to have a go at solving these 3 questions. So hit pause now. 3, 2, 1, pens up, drop, green pens. Oh no, we don't need green pens because it's the end of the lesson. So well done today. You've all done really well. as I was virtually circulating, I saw some good equating to solve these quadratic simultaneous equations. So yes, I understand this is quite a difficult topic, but as I said, you're all capable of doing this, so it's excellent. Remember to keep sending me your work. I love to see your work. There's class chart points available, and make sure that you're doing the homework. Okay, I will see you tomorrow for our last lesson on simultaneous equations. See you next time.